Hello, today our guest is Dr. Ahmed Alawi. He is Associate Professor Sultan Qaboos University. He is going to explain the FTIR microscopy today.
Bismillah ar-Rahman ar-Rahim. Thank you, Professor Shafour, for inviting me today to talk about FTIR microscope. FTIR microscope, like any other FTIR machines, but the main difference is we have two parts. First part is the part that gives the infrared beam, and the second part is the microscope. In the microscope, we have different lenses with different magnifications, where the beam is centered into very small point.
Please watch this video until the end and leave your comments on this video. What is FTIR microscopy? FTIR microscopy is a chemical camera. It contains two powerful tools: optical microscope to zoom and see on a tiny micro-sized location on the surface of a sample, and FTIR microscopy to identify the chemical fingerprint at the microscopic location we are looking at. I could explain it more clearly. First, we could place the sample on the microscope and locate the tiny region. Second, we can use FTIR spectroscopy to measure the vibration of the molecular bonds in this tiny region. Third, analyze the FTIR spectrum to identify the types of the molecules in this region. Therefore, the FTIR microscope can analyze the molecular structure of a material at a microscopic level. It combines infrared spectroscopy and microscopy to provide chemical information in a microscopic location of a sample in relation to their composition and structure. It can identify unknown materials, chemical reactions, and even the distribution or mapping of components in a complex sample. It can apply to pharmaceuticals, polymers, biological materials, and nano-materials.
In the FTIR microscope, we have different options. We can use reflection, and we can use transmission, and also we can use micro ATR. In the reflection option, we use it normally when we have small defined location. However, in transmission, we use it when the concentration is small and we'd like to have high intensity from the sample. ATR, we use it when the concentration or the point that we are looking is extremely small. So we use ATR for that purpose. Here we have three lenses. One is with 4 magnifications, the other one with X15 magnification, and recently we acquired a third lens with 25x magnification to allow us to study less than 1 micrometer materials. For also this particular microscope, we have two detectors: single point detector and focal plane detectors. Single point detector, we use it only for 1 point. However, for focal plane array detector, we use it when we would like to examine large areas. Since we are looking at very small area, we need to reduce the noise as much as possible, and for that we need to cool our detector to minus 200 degrees using liquid nitrogen. In this clip, we are going to analyze microplastics in different samples. So we have here filter paper. We put it in the slide. and then we put it under the microscope for analysis. And we start with the lowest magnification to locate the microplastics first. We'll try to locate the microplastics on the filter paper, and then we focus. Now we are focusing and we search for microplastics. This is not a microplastic, so we need to search in another location. Now we'll use a higher magnification lens. This is X15, and then we focus again. Okay, this is the microplastic. However, as you can see, still the sample is small, so we'll shift to a higher magnification lens, which is X25. This is X25. As you can see, now we have a better magnification and we can see clearly the microplastic. Now we can take a spectrum of this sample. As a procedure in FTIR measurements, we have to take background. And here we are using a lens with low reflectance in order to be used as a background. Here I have already focused my lens and I used a red dot for focusing, so it's focused now. Then I go to a clean area and use that clean area as a background. So this is the background. Before we start the analysis, we need to enter some settings, and the main settings that we have to enter are the number of scans and the resolution. Number of scans for the sample as well as for the background should be the same. Normally we use 32 scans, and the resolution we set it at 4 spherical centimeters. And these are the main settings that we have to enter, which is the same for FTIR measurements. We are searching this sample. We found this interesting sample, plastic. It looks like rubber, so we'll try to analyze it now. So first of all, we need to focus. As you can see, it's focused. However, you see also some dust on the sample. We'll try to avoid that as much as possible by choosing a clean area in the sample, like this. We focus and then collect FTIR spectrum for that sample from that location. So this is the FTIR spectrum for that sample at that particular location. After collecting FTIR spectrum for the sample, then we analyze the spectrum. So this is the spectrum. So what we do normally, we try to search in the library to see if there is any match of this sample to the standards in the library. And here we have the search and result of the search. So the software is telling me there is 51% match with polypropylene. So by this way we can have identification of the samples. After we get the percentage of match from the software, we normally go for another step of confirmation, which is studying the spectrum. As we can see here from the spectrum, in this region, which is around 3,800 to 3,000, we have strong peaks, and those peaks are for CH2 and CH3. And if we look to the molecular structure of polypropylene, we can see that its structure is full of CH2 and CH3, which is giving us a confidence that this is the spectrum of polypropylene. Thank you, Prof. Shafour, for inviting me, and I hope this short clip gave you a clear picture of what microscope FTIR can do and what are the applications of microscope FTIR. Thank you.